in order to describe the object accurately, it becomes necessary to do something called a sectional view of the object. In this illustration, we see the what may be a bearing hub or something that would eventually hold a wheel. And as you can see, it's got a center boss, and it's got a rim, and it's got screw holes. So it is quite complex, and when you cut a section through the middle of the object, pretend you have a knife that cuts through the object. You can expose what the inner workings of the object are, and these are all required in order to manufacture the object correctly. Trying to represent the object in the three principal views, as is shown here, may be possible, but it really does not communicate very well, because you've got an excess of hidden lines, hidden features, and it's not easy to read. Okay, so it according to this, it's hard to visualize the object in this manner. When we cut a section of the object, then we can see where the solid portion of the object is, and where the features such as holes and counter bores or whatever happen to occur on the face of the object, how those are illustrated much more succinctly. Notice that the lines here are all visible solid lines, and there's these 45-degree lines that show wherever solid material is being cut. If I can get my computer to behave, I'll be doing great here. Okay, and then of course in this particular case they're projecting directly from what would be the front view of the object, and then this would be a section of the object. If you notice the arrow here that's accompanied by the letter A, followed by a line that's attached to a line that is broken and dark, that's called a section, a cut line. In other words, this object is being cut along this line, and it's being designated by the letters A at either end. The direction of the arrow points is indicating the direction that you would be looking at the object after it has been cut. So in essence, naturally this would be the view of the object as you view it from the right side after it is cut. You got different objects, and of course whenever you cut an object, you always want to see all of the object lines, including where the object is cut. For example, this particular section cut through the bolt holes, and so you would show the bolt holes, but you also show that the material remains beyond the bolt hole. So you actually see these lines when you do cut the object, and so you would leave those lines on there. This is an illustration of showing you the wrong way to do it, which of course we don't want to do any of these. In this case, they forgot those lines. In this case, they're showing hidden lines, and hidden lines can be used in sections, but are somewhat superfluous in this particular case. And here you're actually showing section lines hidden lines where they actually should be object lines. Sometimes it is necessary to draw hidden lines in sectional views, just simply to clarify that the object does take that form beyond the section itself. You got various objects that can be illustrated better through sectioning. In this case, you've got a box that has a feature within the box, and it's also got a feature underneath the box, which is this hole in the bottom and a hole in the sidewall. It's simple enough to draw a top view of the object and then a section of the object, and that might be sufficient to describe the object completely, because a side view would then just be a rectangle, which may not be necessary. you all would only show hatch materials where the actual solid material is being cut. Illustration is where this object has a gap and you're actually cutting only through the solid material that's in this little L shape. And in this case, you may want to do a couple of sections. One that covers the width of the object, and one covers the depth of the object. And this way you can illustrate the object fairly well with a top view and a section AA in this case, and then there's a section BB, which then gives you a pretty good illustration of the object and its internal works. Cutting plane lines can be drawn into patterns. The most common one, of course, is these long dash lines, dark dash lines, and alternating pattern could be these phantom long dash and two short dashes. Both are correct. Your preference is what's important. Again, always have arrows attached at the end and pointing in the direction that you will be viewing once you cut the section. It's important to locate the section opposite the view from which you would be looking at the object. For example, this section is being cut through the middle of the object, and you're viewing to the left. Therefore, your section should be on the right side, because that would be where you would be viewing the object from. This is incorrect. If you're viewing the object from this is going to the right, so you should be viewing the object from the left, and you should either relocate the sectional view or rotate the direction of those arrows. Okay, these two illustrations, of course, are wrong. If you were to point the arrows in the other direction, then this one would be right. Of course, sections are useful for illustrating things like counterbores, such as this. And again, it is useful sometimes to enumerate these points so that you can keep track of where they lie on the sectional view. In this case, 1, 2, 3, 4 is at the top of the object, so on the section you've got 1, 2, 3, and 4, and then 5, 6, 7, 8 is the little surface there, and then the last series of numbers is at the bottom of the object. So you could just keep track of where your points are. Most of the sections we've been seeing so far have cut across the entire object. In some cases, you may only want to cut through part of the object, or in other words, taking only a quarter of the object out. And in this case, this would be called a half section, not necessarily a full section cuts the object in half. A half section cuts through a fourth of the object, so you only see half of a symmetrical object, and the assumption is that if it looks like this on this portion and it's cylindrical, then it'll probably look the same on the other side. Sometimes you need to break out a little bit of material, or you can pretend that you broke out a little bit of the material just to illustrate a sectional view, such as in this particular case. In this case, that would be a broken out section. Machine parts have a lot of different features. In this particular case, this one's called a keyway, and he cut a section through the object but left the keyway shown as an object view, so that that would not get misconstrued. But he does want to show the threads in the material, solid material of the object in this case. You also have possibilities of showing sections actually where they occur, and just illustrating the cross section, or the actual profile and the hatching of the section exactly where they occur. And in this case, those are called revolved sections, and you can use those in pretty much any profile. If you're seeing it in a plan view or a front view, then you can just create the profile of the section and cross hatch it to indicate that that's the shape of the object if you were to cut it into a section. In this case, you got something like a steering wheel that's made up of a T-section that of course goes all the way around, and spokes that are across a pattern such as this. A very simple revolve section would be a piece of stock that maybe metal stock that would have the pattern of a octagonal shape throughout the length of the object, but you only want to show a profile, within the body of the rod to indicate that it is hexagonal or octagonal in this case. Sometimes you would have instruments that change shapes as they go, and such as a tool of some sort, which would start with a square stock, go into an octagonal stock, and then transition into a round bar. So that's one way to show a complex object with some very simple sectional views. The correct way to draw a rotated or a revolved section is by actually just drawing the section and not including these continuing lines that might be distracting. Just cut the section. It will be understood that the rest of the object looks the way it does. In a case like this, you would when you do cut the section, it actually will be square, such as this. It will not adapt the shape that it's taking in this particular view, but it is of the shape as that's cut in the normal depth dimension. Sometimes it's not practical to show the section where the plan view is shown. So it may be useful to just remove the section, just to indicate that you want to show those particular types of details without interfering with some of the other dimensional information that's on the object itself. So this is removed just to show greater detail how that section is to be drawn or to be manufactured. In a case like this, you've got a variety of sections. You got a section of that loop and a section of the beginning of that hook, and the section at the hook itself. Those are all different, but the profile tells you that this is elliptical, as so is this, and then this has a different shape altogether. Sometimes it is necessary to offset a section. In other words, if you cut a section line and jog it over, jog the section line over just to catch the features, just to include all of the features that are necessary to get this section more definitive and to provide as much information as possible. In other words, I want to show that screw hole, and I want to show how this counter bore is designed, and these slots, I want to cut right through the slot, and of course this is giving me quite a bit of information on this object just with this one offset section. Notice that on the drawing I don't have to show where the offset line took a bend. It'll be obvious by the plan view where that occurred. Sometimes you have an object that may require more than one offset section. For example, section A has a small offset to pick up those screw holes. Section B will again try to cover some additional boss sections. And section C will, again, a different set of circumstances in each one of those parts of that particular plate.